So ladies and gentlemen, in starting chapter 3, what we're going to be doing is we're going to be discussing the systems of equations. So you can see here we have two equations. And what we're going to do is we're going to find the solution of the system, the values that's true for both equations, by graphing. So just like you guys learned how to graph, right, in slope-intercept and standard form, and that's basically all we're going to learn. That's basically all we're going to do here is just graph two separate equations. So we're practicing more graphing. Yippee. So the first one we're going to do is just take y equals -1/2 x plus 5. So just remember graphing. This is your y-intercept, which is the coordinate point 0, 5. Slope is not a point. It's a ratio. So -1/2 is equal to -1/2, which is also equal to 1/-2. Remember, slope is just a ratio, the change in the y-coordinates over the change in the x-coordinates. OK? That's all slope represents. Where here is a point. So let's go ahead and graph this line first. So what we learned in this class from graphing is we find our y-intercept first. 1, 2, 3, 4, 5, right? Because that's the y-intercept, that's the x-intercept. Correct? Plot the y-intercept. Now we use the slope. Now, I have 3 different slopes up here, right? So which one to use? It doesn't matter. But the best thing that I like to do is put the negative sign, and rather than having the negative sign in front, I like to put it either in the numerator or the denominator. Because remember, slope, sometimes we say rise over run, but it's the change in the y-coordinates. So if the change in the y-coordinates between any 2 points is -1, from my y-intercept, I need to go down 1. And if the change in the x-coordinates is +2, then I'm going to go over 2 units. See how that's -1/2? If you did this one, change in y-coordinates was +1, then you'd go up 1. And if the change in the x-coordinates was -2, you'd go left 2. But either way you guys look at it, I want you guys to see that this line, all these points are going to lie on the same line. Now, my line's a little ugly, but hopefully you guys get the idea. It doesn't matter which one of these you use. You're just going to have to pick one and go with it. Now, we got 1. Now let's go and graph this. Now, this is not in standard form, but it's not in slope-intercept form. So what I would prefer to do is solve this for y and graph it in slope-intercept form like I did here. So to do that, I'd subtract 8 on both sides. Now I have 2y is equal to 8x minus 8. Now I divide by 2. Y equals 4x minus 4. OK? Matt, you done yet? Yes. What's the question? This one was already in slope-intercept form. Y equals mx plus b. This one was not. So I had to solve for y. So now it is in mx plus b. So now I know my slope. But look it. See, here the slope was a fraction. Here, I don't have it as a fraction. So I need to write it as a fraction. Here, this is my y-intercept, which is 0, -4. So now I plot that one at 0, -4. 1, 2, 3, 4. Now, again, I use the slope. Change in y is positive. Change in x is positive. So I go up 4 over 1. Up 4, 1, 2, 3, 4 over 1. So what you guys can see is these two lines intersect at a point. And that point is 1, 2, 1, 2, 3.